To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter, we discussed about the electrolytes and the non-electrolytes. Okay, so within the electrolytes, we discussed that electrolytes are the ones or the solutions that has mobile ions, and non-electrolytes are the ones or the substances or the solutions that has that do not have mobile ions. Okay, so under the examples for electrolytes, we studied about solutions of solutions of ionic compounds, acidulated water, solutions of acids, and solutions of bases. Especially we were discussing about the electrolytes and the non-electrolytes in the previous lesson, and we have identified how does the electricity is going to transfer or to conduct from a solution, right? So we discussed that electricity means a beam of electrons. So these beam of electrons are getting transported from one place to another if there are mobile ions, so that the mobile ions can attract or repel electrons towards a certain direction. So when electrons are being moved to a certain direction through a certain object or through a certain solution, then we can say that the solution or the object is going to conduct electricity. So by that way we studied that solutions are conducting electricity mainly because of having mobile ions in it. Okay, so now my dear children, we are going to discuss how to bring a chemical reaction or how to result a chemical reaction by using this electrolyte, right? Here we need to provide electricity. So within this chapter, we'll be discussing mainly about changes caused in a solution by an electric current. Changes caused in a solution by an electric current. So this is the main topic that we are about to discuss within this lesson part. Okay, so we'll be using several solutions, especially several electrolytes here. Okay, solutions that can pass electricity, and we are going to provide electricity by using carbon or graphite rods, and after that we are going to observe what has happened to the electrolyte when providing electricity. What are the special observations that we can see within the electrolyte when passing electricity through it? So we'll be mainly focusing about those things within this lesson part, my dear children, or within this chapter. So you are given with an experiment, and within this experiment will be using our first and foremost type of electrolyte to identify about the things or the observations that's going to happen within an electrolyte when providing electricity. So my dear children, here we are using these substances, right, these materials, and to observe what is going to happen within the solution or within the electrolyte when providing electricity. So first of all, you'll be needing a beaker, then an ammeter. So like I said, it's better to use a center zero ammeter, right? It's better to use center zero ammeter. Then you'll be needing to connect the system, you'll be needing connecting wires. And here within the blue color solution, you can observe a blue color solution over here. So this blue color solution, you know my dear children, this is copper sulfate solution. Copper sulfate solution. Then over here, to provide electricity to the setup, we'll be needing carbon, or else you know that this is made up with graphite rods. Carbon or graphite rods. Then will be needing dry cells. To provide electricity, as an electric source will be needing dry cells. So it helps to provide electricity to the circuit. So these are the materials that we need, my dear children. We'll be needing a beaker, an ammeter, some connecting wires to connect the circuit, a copper sulfate solution. This is our electrolyte. Okay, I'll write it as the electrolyte. This is the electrolyte that we use. Okay, we use that electrolyte to observe what kind of a change caused in the solution when providing electricity. Okay, so that is the electrolyte that we have, copper sulfate solution. Then carbon or graphite rods to provide electricity to the copper sulfate solution or to the electrolyte. Then we'll be needing a source of electricity, dry cells in here, to provide the electricity to the solution. So these are the materials that we need, my dear children. So we are going to provide electricity to the solution, and we are going to observe what kind of a thing is going to occur within the solution. Okay, right. Now let's head on to see the method of doing the experiment. Okay, so let's observe the method of doing the experiment. So here you are given with a figure. It's very easy. So this is the diagram, my dear children. So here you can observe beaker with copper sulfate. Solution. So this is the beaker with copper sulfate solution. So you have to take that beaker and you have to pour some copper sulfate solution into it. Then what you have to do? Like this way, you have to dip the two carbon rods. So these are the carbon rods. These carbon rods which used to provide electricity to the solution are referred as electrodes, my dear children. Electrodes. Okay, we'll be studying about these things when you go further with the lesson part about the electrodes. Okay, so electrodes are the ones, in simple we can define that the electrodes are the ones which can be placed into the liquid or into the electrolyte to provide electricity. Okay, so carbon or graphite are good conductors of electricity. So therefore these are the ones which can be used as electrodes. Okay, electrodes. Right, so we'll be learning about electrodes in the later part of the lesson. Okay, right. So these are the electrodes then. So electrodes and the beaker with copper sulfate solution. Then you know that these are the connecting wires, the dry cells and the ammeter connected. So what you have to do, first of all, you have to take the substances and the materials and you have to construct this apparatus or construct this system according to the given diagram. Okay, and you have to complete the circuit by connecting the wires. So we'll write down the first and foremost step. What do you have to do? Prepare the system according to the given diagram. According to the given diagram using carbon rods, ammeter, carbon rods, ammeter, dry cells and the copper sulfate solution. Right. So the first step, very simple. Prepare the system or the circuit according to the given diagram using carbon rods, ammeter, dry cells and the copper sulfate solution. So by using those materials, we have to prepare this system over here. Okay. Then turn on the circuit. Means that if you want, you can, I told you that when you are doing this electrolysis process, if you want, you can use a switch. However, we'll be needing to turn on the circuit, right? And we need to observe what is going to happen with the solution after few minutes. So turn on the circuit and observe the changes. Observe changes. Turn on the circuit and observe changes after few minutes. Right? So you need to now turn on the circuit and you need to observe the changes after few minutes. Right? So this is how, or this is the way of doing the experiment. It's very simple, my dear children, a very simple experiment. What you have to do, it's very simple. You take the system like this and you prepare the system according to the diagram given. You dip the two carbon rods into the copper sulfate solution and you connect the two carbon rods to the dry cell like that through the ammeter. Remember, these two carbon rods should not touch each other, right? Otherwise the current or the electricity will flow through these two carbon rods together and the electrolyte will not receive electricity. Okay, so here we need to pass electricity through the electrolyte or through the copper sulfate solution. So electricity should come over here, from here through the solution to there, and like that. Okay, the electron should travel through the solution, right? If you join these two together, then electrons will come and directly travel to the other carbon rod as they have been contacted with each other. So remember not to touch these two rods together. That's very important. Okay, my dear children. So here, this is the way of doing the activity, my dear children. So let's head on to the laboratory and we'll conduct the experiment. Okay, and we'll see what are our observations and our conclusions from the experiment, my dear children. So my dear children, within this activity, will be electrolyzing this copper sulfate solution. For this electrolysis process, I'm going to use two carbon rods like this. These are carbon rods. Then let's dip these two in the solution. So this is the ammeter, a dry cell, and the switch to turn and off the circuit. Now let's connect these two. The red color terminal indicates the positive terminal. Red color indicates the positive terminal. So this is positive terminal. And the black color terminal indicates the black color terminal. This one indicates the negative terminal. So here we go. I'm going to turn on the switch. So as you can see here, as soon as I'm going to turn on the switch, there's a clear deflection in the ammeter. Ammeter reading is showing now a value of a 0. Now it has been connected to the 3 ampere over here. So it's showing around 0.5 of a reading. Okay, the reading is actually not that much important. As you can see here, some kind of an electricity is going to flow. through the ammeter. That's why it is showing a reading. So it's around 0.5 right now. So we'll check the terminals. So there is no such difference in the negative terminal, but however we have to take it out and observe. However, my dear children, within the solution, this is the red color terminal. Red color terminal is the positive terminal, right? So positive terminal is going to emit, see, gas bubbles. So it's emitting gas bubbles. Positive terminal is emitting gas bubbles, right? So let's keep the system for a while. Then we are going to check about the solution color. So in order to observe the color, my dear children, we have to keep the system for a while. So let's keep the system for a while within the same position, within the turned on position over here. As you can see, there are plenty of bubbles now coming out from the positive terminal. So we'll keep it for a while. Then after, we'll observe what happens with the color, and I'm going to take out this negative terminal, right? And I'm going to observe and I'm going to show that what has happened with the negative terminal or to the negative electrode, which is inside the copper sulfate solution. So we'll keep the system for a while and let's observe what has happened with the color and what has happened with the negative terminal of the setup. So my dear children, as you can see here, now the rate of air bubbles which is coming from the positive terminal dramatically reduced. And also you can see that there is a clear weave of the solution as well. There is a clear, very clear weave. In the earlier, when I was starting this practical, my dear children, you are unable to observe what has happened with the negative terminal. There was no clear observation, but however now you can observe there is a deposition around the, right, there is a like copper color deposition around the carbon rod. But in the previous instance you can't observe it because the color of the copper sulfate was in like dark blue color, but however now it has been dramatically changed, right? Even we can observe there's a very clear copper nature within the negative terminal of the electrode, right? So there is a clear difference in the color. Color of the solution has been reduced. There's a clear reduction in the color, my dear children. So let's turn off the switch and now we'll take out the negative terminal and observe very clearly what has happened with the negative terminal. See, as you can see here, there's a brownish color deposition around the, see, it's very clear to us. There is a brownish color deposition around the carbon rod of negative terminal. So here once again you can see this is the positive terminal which is in the red color. So this is still within the solution. So I have taken out the negative terminal. So there is a clear deposition of copper within the negative terminal. This is copper, my dear children. You can see it very clearly, right? And you even identify this color. So this is copper. This brownish color substance is copper. So by doing this activity, we can finally conclude that these are our observations. The copper metal, this is copper metal, no? So copper is going to deposit on the negative terminal. The color of the solution has dramatically been reduced right now. And the positive terminal is going to emit gas bubbles. So we'll head on to the classroom and write down our observations. Then we'll come into conclusions. Right then. So my dear children, we conducted the activity. Okay. And we could observe that there were three different observations. There were three different observations. Right. You could observe that there was a reddish color substance, right? There was a reddish color substance, actually a brown color substance, reddish brown color substance, right? We'll write it now. We'll write that thing as a reddish brown color substance. That is more suitable, no? So a reddish brown color substance was deposited within the negative terminal On the negative terminal, we could observe a reddish brown color substance. That was the first observation. So you have to keep this system for a while, right? Like 30 to 15 to 30 minutes. So if you keep it like 15 to 30 minutes, then you can observe these things without any trouble. Okay. So first and foremost thing is there was a reddish brown color substance on the negative terminal. So we can write down the first observation, reddish brown color, reddish brown color substance. Reddish brown color substance deposited on the negative electrode. Right, on the negative electrode. Electrode means carbon rod. Okay. So reddish brown color substance deposited on the negative electrode. This is the first observation that we observed when we are doing the experiment, my dear children. Okay. Then the second one. So during the deposition, or when this thing is going to deposit, my dear children, you could clearly observe that the gas bubbles are emitting from the system. From the solution, gas bubbles are going to emit. But however, it is especially observed within the positive terminal or near the positive electrode. So near the positive electrode or near the positive carbon rod, gas bubbles are liberated. Gas bubbles are liberated. Okay. So gas bubbles are liberated near the positive terminal. So we can write down the second observation then, near the positive electrode, right, near the positive electrode, gas bubbles right, near the positive electrode, gas bubbles evolved. Right. So near the positive electrode, my dear children, gas bubbles evolved. Then the third and the final observation, when few hours, or when few minutes are going to pass by, you could clearly observe that there is a decrease or there is a reduction in the color of the copper sulfate solution. The color has got reduced somewhat. So that was our third and the final observation from this setup. So the third observation is really simple. When doing this experiment for few minutes, we could clearly observe there is a color change. Here the color has reduced, right? Color has reduced. So the color contained within the copper sulfate solution reduced somewhat. Color has faded. So we can write down the third observation. Color so we'll mention the blue color, that's more convenient. Blue color of the solution was reduced, right? Blue color of the solution was reduced. So these are the three main observations that we could took from the experiment. Number one, my dear children, you could clearly observe that there was a reddish brown color substance deposited on the negative electrode or the carbon rod. Electrode means the carbon rod. Then the second one, near the positive electrode, gas bubbles evolved. Near the positive electrode, we could observe that the evolution of gas bubbles, right? Then third one, blue color of the solution was reduced. Blue color, there was a good blue color when we are starting the experiment. However, when providing electricity, gradually that blue color was reduced. Okay, so this is the third and the final one. Blue color of the solution was reduced, right, when providing electricity. So these are the three main observations that we can take from the experiment, my dear children. The three main observations, right? So now let's head on to observe the conclusion. So we know that, my dear children, in order to occur a certain chemical reaction, at least one of these things should occur. What kind of things? Gas bubble should evolve. Then change in the color of solution or any other substance. Then evolution of different smokes or any other gases. Okay. Then, my dear children, deposition of a substance. So this was also referred as if a substance is going to deposit within a certain solution without going into a solution, I mean, like if it is getting suspended in a solution, right? So suddenly a substance, kind of a substance, is going to suspend on a solution, right? The solution is the one that we took originally. There was no any other substance, or there was no any other solution. There was no any other solid substances contained within it. However, after some time, if a chemical reaction is going to occur, a certain solid substance would come, and that solid substance will not go to the solution. So that kind of a one is referred as a precipitate. Okay, so if there is a precipitate, then we can say that the chemical reaction has happened. So like that, there are several things. So I have provided only few examples here. So if there is a emission of energy like sound or heat or any other forms, if there is a liberation of gases, if there is a color change, if there is a precipitation, right, then we can say that there is a chemical reaction. Right? We studied these things under the grade 8 also, my dear children. In order to show that there is a chemical reaction, we can use these observations. Now, by looking at these observations which we took from the experiment, we can come into a conclusion that when providing electricity, electrolyte is going to provide or is going to change chemically. Okay, that means the electrolyte is going to provide a chemical reaction upon providing electricity to it. These observations that we took is going to support that particular sentence, because when there is a certain chemical reaction is going to happen, new substances are getting produced. If there are new substances, definitely what will happen? Some kind of a deposition or else a precipitation could be observed. Evolution or liberation of gas bubbles could be observed. See? And there is a color change also. There can be a color change. So all of these three observations shows that when providing electricity to the copper sulfate solution, a chemical reaction has occurred within the solution. Right? Within the solution, upon providing electricity, a chemical reaction has occurred. When we are disconnecting the electricity, my dear children, we won't be able to observe these things. Right? So it is only available when I am providing electricity. only available when I am providing electricity. So my dear children, we can come into a conclusion, a final conclusion. When providing electricity, the electrolyte is showing a chemical reaction, right? A chemical reaction. So, or else within the electrolyte, when providing electricity, chemical reaction occurs. So we'll write down our conclusion in the next one then, right? So I'll use the bottom here, over here to write down the conclusion. So what is our conclusion? It's very simple. So what is our conclusion, my dear children? A chemical reaction has occurred, or a chemical reaction is giving out when providing electricity to the solution or to the electrolyte. So we can write the answer. A chemical reaction has occurred when providing electricity to the solution. Here we'll mention as the electrolyte. Right. So our final conclusion is, a chemical reaction, right? A chemical reaction has occurred when providing electricity to the solution or to the electrolyte. Chemical reaction is the final result, right? When we are providing electricity to the circuit, chemical reaction is going to occur. That's the final conclusion, right? So let's head on to see what are the other contents in the lesson part. When electricity is conducted through an electrolyte, the conductors through which the electric current enters the electrolyte and exit are called electrodes. Now, electrodes are the materials or the substance that we are going to provide the electricity, and the electricity is coming out from the other one. So when electricity is conducted through an electrolyte, the conductors through which the electric current enters the electrolyte and exit are called electrodes, right? Electrodes. So here, once again, my dear children, when electricity is conducted through an electrolyte, when electricity is going to conduct through an electrolyte, the conductors through which the electric current enters the electrolyte are now, electricity is going to enter through one electrolyte and exit are called electrodes. So from one certain electrode, electricity is going to enter to the electrolyte, and from another it's going to exit. So in here it is given, especially when electricity is conducted to the electrolyte, the part or the system or the unit which enters electricity into the electrolyte and which is coming out are referred as the electrodes. These things are referred as electrodes. See, electrodes. So when electricity is conducted through an electrolyte, the conductors through which the electric current enters to the electrolyte and exit are called as the electrodes. Okay. So here specially we use these things, right? Here specially we use electrodes as carbon rods. Normally we use carbon rods, right? So let's see what are the other contents. The electrode connected to the positive terminal of the external supply of electricity is called the positive electrode. So the electrode which is connected to the positive terminal is the positive electrode. Okay, so the carbon rod which is connected to the positive is the positive electrode. The electrode connected to the negative terminal of the external supply of electricity is called the negative electrode. So, in the external electric source, right, when you are taking the external electric source, the electrode which is connected to the negative terminal of the external electric source is referred as the negative electrode, and the electrode which is connected to the positive terminal of the external electric source is called as the positive electrode. So through positive electrode, electric current comes and it is going to pass through the negative electrode towards the negative terminal. You know that the electron flow is going to happen to the opposite direction of that, right? But however, we are talking about the electric current, no? So electric current is coming from the positive terminal and going towards the negative terminal. So I have explained about the electric current and the direction of electron flow when I was discussing about the previous chapter. Okay, so there are two electrodes, my dear children. So from these electrodes we provide electricity to the solution or to the electrolyte. Electrode connected to the positive terminal is referred as the positive electrode. Electrode connected to the negative terminal is called as the negative electrode. So electric current comes through the positive terminal and going towards the negative terminal. That's how the electric current is going to flow. So the next point, in the above activity it can be observed the deposition of a reddish brown substance at the negative electrode. So we wrote this thing, deposition of reddish brown substance at the negative electrode. Liberation of gas bubbles at positive electrode. So I'll use a different color here. Liberation of gases at the positive electrode. Liberation of gas at the positive electrode. Then finally, as number 3, gradual decrease, right? Decrease in the blue color, right? Decrease in the blue color. So the 3 observations: deposition of a reddish brown substance at the negative electrode, liberation of gas bubbles at the positive electrode, then gradual decrease in the blue color in the solution. The 3 observations. Hence it is clear that the compounds contained in the beaker undergoing a what? A chemical reaction. So it is obvious to us that these, right, within the beaker the substances undergo in a chemical reaction. Within the beaker the substances or the chemical or the electrolyte is undergoing in a chemical reaction upon providing electricity, right? So the first and foremost change caused in a solution by an electric current is resulting a chemical reaction. However, it should be an electrolyte so that it could pass electricity from one place to another. So when you are providing electricity to an electrolyte, okay, when you are providing electricity to an electrolyte, the first and foremost observation is that we can result or we can generate a chemical change. Okay, when providing electricity to an electrolyte, we can result a chemical change or else a chemical reaction, my dear children. This is the first and foremost observation that you can take when providing electricity to an electrolyte. The result is a chemical change or else a chemical reaction. So this chemical change is caused by the electric current passed through the solution. Here copper is deposited on the negative electrode. See, copper is deposited on the negative electrode. Copper, that is why it is having that reddish brown color. You know that the reddish brown color is the unique color of copper, right? So the copper is getting deposited within the negative terminal within this experiment. When doing this experiment, copper is getting deposited on the negative terminal, right? When doing this experiment, it is obvious to us that copper is the one which is getting deposited on the negative terminal. How can you say that? By using that reddish brown color, right? Reddish brown color is unique to copper. So copper is the one which is getting deposited on the negative terminal. Oxygen gas is liberated at the positive terminal. The gas which is liberated is the oxygen gas. From the positive terminal, my dear children, from the positive terminal, oxygen gas is the one which is getting liberated. Oxygen gas. So oxygen gas is liberated from the positive terminal, and on the negative terminal, the copper metal is getting deposited. Copper metal is getting deposited. Okay. Copper sulfate undergoing the chemical change has turned into copper, a simpler substance. Now, earlier it was copper sulfate. Now, copper sulfate, you know that copper sulfate is made up with joining of two different substances, copper and sulfate. Copper is having a plus charge, sulfate is having a minus charge. Together, they bond to create the copper sulfate substance. Once again, you know that when we are making a solution, these two are getting separated within the solution, but however, we can observe copper sulfate solution. Okay. So in the copper sulfate solution, my dear children, copper is present as ions, as copper plus, and sulfate is as negative ions. Okay. So the copper ions present within the solution converted into copper solid. Okay, converted into copper solid, and it is getting deposited on the negative terminal. Here we can say that when giving electricity to an electrolyte, the electrolyte is getting converted into very simple substances. Earlier, copper sulfate was a compound, but now copper is a simple solid. Earlier it was a compound, now it is an element. Copper is an element, no, made up with only one type of atoms. So in the earlier, but however it was a what? It was a compound. So compound is made by joining several few numbers of atoms. So in copper sulfate, copper, sulfur and oxygen is there. So it is a compound, somewhat complex. However, when it is getting converted into copper, right, upon providing electricity, copper sulfate now breaks down into simpler substances. Okay. So we can conclude finally, copper sulfate undergoing in a chemical change has turned into copper, which is a simpler substance. Now, the definition of electrolysis. See, chemical change effected by passing an electric current through an electrolyte is known as electrolysis. Electrolysis. So what is electrolysis, my dear children? Electrolysis is the process of generating an electric current. The process of generating an electric current through an electrolyte, right? Process of generating a chemical reaction, not an electric current. Process of generating a chemical reaction by providing electric current. So, chemical change effected by passing an electric current through an electrolyte is known as electrolysis. So, here we provide electricity to a certain electrolyte, and the result that we take is a chemical reaction. Okay. The result that we take is a chemical reaction. We provide electricity to a certain electrolyte, and within the electrolyte a chemical reaction is resulted. This process is the one which is referred as electrolysis. So remember, electrolysis can be done only for an electrolyte, not for each and every solution in the environment. The solution should be able to, or the solution must be able to conduct electricity, right? That means it should be an electrolyte. So if it is an electrolyte, means it can conduct electricity. Okay. So electrolytes are the ones which can be converted into simpler substances by providing electricity. Means that electrolyte is going to undergo in a chemical reaction when providing electricity to it. Right. So my dear children, electrolysis is the process of generating a chemical reaction by providing electricity to an electrolyte. Okay, to an electrolyte. Right then, during this process, the electrolyte is converted into more simpler components. Now here, electrolyte is getting converted into more simpler components. Very simple components. Okay. A substance that doesn't react chemically with the electrolyte is referred as inert electrodes. Now the other thing is that now our result should be a chemical reaction. What will happen if you put a certain substance to provide electricity to the electrolyte? Okay. Now that particular substance is going to react with the chemical solution. Now that is going to be a huge problem. Why is that? Because our result should be a chemical reaction, but after providing the electricity, not before it. So therefore, when you are selecting electrodes or the substances that need to provide or that need to supply electricity to the electrolyte, the electrode which you are going to use should not react with the solution or with the electrolyte. Okay? There shouldn't be any kind of a chemical reaction. Chemical reaction should only be obtained after providing the electricity to the electrolyte. So the electrolyte that we are going to use should not react with the electrode or the material that we are going to put into the system to provide electricity. If those two are reacting to each other, then the process of electrolysis is not going to happen, my dear children. Okay. So it's important to select a substance which is not reacting with the electrolyte when you are selecting the electrodes. So these electrodes which are not reacting with the solution is referred as inert electrodes. Inert electrodes. Okay. Inert electrodes. So here carbon or graphite and platinum electrodes are such examples. Platinum is a metal, my dear children. The most expensive metal in the world is platinum. This is also referred as white gold. Platinum, right? So it is the most expensive metal present within the world. Platinum. So usually we use carbon rods, because if you are going to use platinum rods, my dear children, then you won't be able to use, or you won't be able to do that thing in our normal laboratory conditions, because you know that platinum is much expensive. Even it is more expensive than gold. So we won't be able to find platinum electrodes in our normal laboratories. Okay. So in our school laboratories, in our normal laboratories, we use carbon electrodes to provide electricity. Carbon is an inert electrode. So as platinum, but however platinum is much expensive. So we won't be able to find platinum electrodes in our normal laboratories. Okay. However, platinum is also can be used, remember, as an inert electrode, because it is not going to react with, right? It is not going to react with the solution. Okay. Right. So these electrodes should not react with the solution during the electrolysis process. So the electrodes that we use to provide electricity right, should not react with the solution. So these electrodes are referred as then inert electrodes. So when providing electricity, my dear children, through inert electrodes, electrolysis process is going to happen. What is electrolysis? Electrolysis is the chemical change effected by passing electric current through an electrolyte. So what is the result in this thing? Like what kind of a chemical reaction is going to happen? What kind of a change is going to happen within the electrolyte? What is that? Here the electrolyte is getting converted into simpler components. For an example, if you take copper sulfate solution, copper is created from the copper sulfate compound. Compound is a copper sulfate. Copper is getting created when providing electricity to the solution of copper sulfate. So copper is a very simpler element rather than the copper sulfate, as it is a compound, right? So this is what does electrolysis is. Okay, this is what electrolysis is, my dear children. So here within the electrolysis mainly we are resulting a chemical reaction, right? Now let me explain about, how does this process which the deposition of copper is going to occur. Okay, so my dear children, I'll take this thing somewhat up and let me explain how does the deposition of copper is going to happen within this system. So I'll draw it. So this is copper sulfate, the electrodes. And now we are providing electricity. So this is the positive electrode, this is the negative electrode. You know that in a dry cell, right? The longer terminal is the positive. So this is the positive electrode, shorter terminal is the negative. So this is the negative electrode. So within the solution, my dear children, you know that copper is found as copper plus ions. And the other one is sulfate, SO4 minus ion. Okay, I think you would remember copper sulfate, CuSO4. Copper is separated as positive by removing electrons. You know that copper has the ability to remove electrons. Copper has the ability to remove electrons as the electrons and the particular nucleus of an atom has weaker bonds, right? Weaker attractions. So these electrons has the ability to move here and there freely. We discussed that thing when I was discussing about the conduction of electricity in metals. When we are discussing about the ability of conducting electricity in a metal, I told you how a metal is going to conduct electricity, right? So here copper plus is created by donating or by giving electrons to the sulfate group. Okay, voluntarily copper is going to give electrons to the sulfate group. As copper is having weaker attractions between the nucleus and the electrons which is revolving around it. Copper has that ability. Each and every metal has that ability to remove electrons. Okay. So by removing electrons, it is giving that, so copper is giving that electron to the other particular compound or to the substance. In here, sulfate is that group. So copper is removing electron and giving that electron to the sulfate group. Now copper is in this thing, this state. This is the one which is referred as an ion. So if you want to recreate copper, I mean the copper metal. If a copper metal, in the copper metal, my dear children, copper metal, the copper atom is having same number of electrons, not like here, but before it. So copper sulfate is made by removing electron and taking an electron by the sulfate group. So when removing the electron, copper is getting positive and sulfate is getting negative. That's why these two are getting attracted to each other due to that strong static electrical charges. In the same way, these things are getting separated within the solution. So how you can make copper solid or the copper metal by using the copper ion? Very simple. What do you have to do? Once again, you have to take the electron from sulfate group or else from any other component, and you need to embed that electron once again to the copper, right? Copper ion. So by that way, this positive one will disappear, because you know that when you provide an electron to the positively charged copper ion, positive and negative charges are cancelled off and the solid copper can be created. Right, so once again let me explain. Okay, my dear children, copper sulfate is created like this. Like how? Copper sulfate is created. This is copper sulfate. So copper atom is going to donate the electron that they have to sulfate group. Sulfate then receives that electron, and because of receiving electrons, which are the bad behaviors, can you remember? Electrons, negative, bad behavior. So it becomes negative, bad. Upon removing an electron and giving it to this guy, copper receives a positive charge. These positives and negative charges are static electrical charges, so they get bonded each other, creating copper sulfate compound. When you pour water into this, these two get separated and they can freely move here and there within the solution. But however, still copper is missing that electron which was given to the sulfate. Sulfate is having that thing and copper is not having that electron. So therefore, still there are ions like this, but however, these ions are freely mobile here and there within the solution. That is why we define those things as mobile ions. So now we need to create copper. In order to create copper, that missing electron should be provided to copper. By that way, copper metal can be created. So it's very simple. Copper is removing an electron to become copper. Plus, when you give an electron to copper, it becomes again into copper metal. Right? This is how the reaction is going to work now. Remember that case. So now, my dear children, within the system, there is copper. Now the other special thing. This is the negative terminal, this is the positive terminal. You know that copper is having a positive charge. Copper is having a positive charge. If copper is having a positive charge, my dear children, then that positively charged copper is attracted towards the negative terminal of the system. Why is that? Opposite charges? No, obvious. Like a magnet attracting north pole to a south pole. Right? North pole, south pole attracting. Plus and minus attracting. Copper plus attracting to the minus terminal in the system. Now you know, my dear children, what's going to happen. See, electrons are coming through the negative terminal, and now what will happen? They will come across and they will come in contact with these copper ions. So what will happen? The previous thing which I had told. When copper receives electrons which were given to the sulfate once again, all of the electrons are identical, right? There is no problem in receiving electrons from a different source. No problem in it. All the electrons are identical. So therefore what will happen, my dear children? The electrons which are coming towards this terminal will will come in contact with the copper plus, or else the copper positively charged copper ions, and what will happen? These electrons will once again turn these positively charged copper ions into copper solid. So that is why copper is getting deposited at the negative terminal. This is now obvious to us. See, this is how the deposition is going to happen within the negative terminal, because the copper is receiving these negatively charged electrons at the negative terminal. Like I said, my dear children, in a dry cell, electrons are plenty available in the negative terminal. So negative terminal, within the negative terminal, copper receives the electrons, right? And it becomes the copper solid. So all the positive charges are now going to disappear. All the positive charges are now going to disappear as they receive what? As they receive electrons from the electric source coming over there. And now the copper metal is deposited on the negative terminal as they receive electrons once again. Right? Then the second one. The blue color nature of the copper sulfate. Blue color nature of the copper sulfate solution can be observed, right? Blue color nature of the copper sulfate solution can be observed, my dear children, because of copper plus ions. Blue color nature is given out because of copper plus ions. Now the copper is getting converted into copper solid. So what will happen? Definitely the blue color will reduce, because there is no ion, no copper plus ions to provide the blue color into the system. So what will happen? Blue color will gradually reduce. Then the other case. Other case is somewhat different. Within the system over here, my dear children, there is sulfate ion, and I told you that when substances are mixed with water, you know that water is getting separated into hydrogen plus and OH minus. Okay, so you will be learning about the process of electrolysis in grade 11 also. Not in grade 10 but in grade 11. In that case, we will be identifying further somewhat advanced theories related to the electrolysis process. Okay, so by that day you will get to know how does this process is going to occur with reasons. Okay, up to now I am going to just explain how this is going to happen. So in water, this OH minus ion is the ion which is getting attracted to the positive terminal, right? This SO4 minus ion is not getting attracted. Actually, it is getting attracted, but however, it doesn't have the ability, right? It doesn't have the ability, right? It doesn't have the ability to create a change in the system, like in the hydrogen plus ions over here. Okay. So hydrogen plus ions created by breaking down water is also going to attract to the negative terminal over here. But however, it doesn't have the ability to change into a certain other type of a substance. Okay. Copper is the one which is undergoing in a change. in over here, the negative one, OH minus ion, OH minus 1 is the one which is going to change. This OH minus ion is going to break down and create oxygen gas. And it is going to create oxygen gas. Always, if OH minus is there, I mean like if you are using an aqueous solution, always OH minus ion is the one which is going to place on the positive terminal and it is going to create oxygen gas, right? And it is going to create oxygen gas, okay, if OH minus is there, okay. So these are somewhat further clarifications, my dear children. When you go to grade 11, you will identify how to clarify these things in detail and how to select these metals and how to select these ions to the relevant places, and with reasons you will write down these things in grade 11. Just for now I am giving out a simple explanation, okay. So what will happen here, copper will deposit on the negative terminal and it will receive the electrons, and copper will deposit on the electrode itself by receiving electrons. H2O is separated to H plus and OH minus. This OH minus 1 is attracted to the positive terminal and that OH minus is creating the oxygen gas which is going to bubble from the positive terminal, okay. So this is how the changes are going to occur. So the unique blue color of the copper sulfate solution is obtained mainly because of having copper plus ions. So copper plus ions are now not available in the system or less available in the system because what? Because, my dear children, copper plus is going to receive electrons which is going to come from the negative terminal and it is getting converted into copper solid like this, okay. So therefore the color of the solution is gradually decreasing. Color of the solution is gradually decreasing. Blue color is gradually decreasing. What is the reason? The reason is, my dear children, because of losing copper ions, right? Because of losing these copper ions, copper plus ions. Because these copper plus ions are now going to receive electrons and deposit as copper solid within the negative electrode. This is what happens in detail. So I hope that you got a good knowledge about the process of electrolysis, right? Each and every change that is going to happen within the system is created mainly because of providing electricity to the positive terminal. Negative ones are attracted to the negative terminal, positive ones are attracted. When electrons are coming towards the electrolyte, these negative ions are getting electrons and they are getting changed into a different substance. All of these changes are going to happen only because you provide electricity to here. So that is why it is called as the electrolysis. When providing electricity, the ions present within the solution undergoing different changes, creating other substances, resulting in a chemical change. Okay, so this is how does the, right, or this is the way that the electrolysis process of copper sulfate solution is going to happen with reasons. Okay, so I hope that you got a good knowledge about the process of electrolysis that is going to occur within the copper sulfate solution, my dear children, right? So this is the electrolysis process which is going to happen within the copper sulfate solution. So once again, there are three observations. Copper is deposited on the negative terminal. Blue color solution is going to gradually reduce the color. Oxygen is going to evolve from the positive terminal. All because of providing electricity to the electrolyte. Right then. So I hope that you got a good knowledge about the process of electrolysis, my dear children, right? So here we discussed about the changes that is going to occur within an electrolyte when providing electric current. We discussed that within the electrolyte, the substances are getting converted into much simpler substances when providing electricity, right? So electrolysis is the process of generating a chemical reaction by providing electric current. And my dear children, during the process of electrolysis of copper sulfate solution, we discussed that copper is deposited on the negative terminal, blue color is going to reduce, and once again oxygen is going to liberate from the positive terminal. So these are the observations, and this is the first type of electrolysis that we are going to discuss within this lesson part, right? So with that, my dear children, I'm going to wind up my third chapter. Within the next chapter, we'll be discussing about another electrolysis process. However, we'll be using a different kind of a substance here, or else an electrolyte, right? However, we'll be discussing that electrolysis in our next chapter. So I hope to meet you with the next chapter to discuss about further things related to the lesson.